Hertz.
Wait a second, we're missing something.
Hertz.
Or linear hertz, yeah, as Ibrahim might say.
Mm-hmm.
All right, what's the period?
Tangential hertz.
All right. Translational hertz?
Rotational hertz.
That would be up there. Anyway, what's the period?
6.9541. Seconds.
All right, we're cruising. We haven't touched on energy yet, we've got that, we're looking all good, except for we got these equations right here. We got the set of equations. And by the way, and I'm not necessarily going to do it, but if you ever see a question with a gift icon next to it, that usually means that the answer is in the question itself.
What's the gift icon?
It basically looks like a box with ribbon.
Oh, okay. What if you just put it there to trick us?
That is a possibility too.
Okay.
Or I misread my own question. But usually, the times that I have remembered to do it, and the reason it's triggering is I had a problem like this in the past where I think I gave the frequency, and the first question is, what's the frequency? And just always shocked at the number of people who miss it. It's because they didn't recognize hertz as a unit of frequency.
Linear hertz, I'll tell you.
Yeah. Or as the cool people say, hertz.
Well,
You're taking physics, so there's a limit there. All right. One thing we have to do before we actually can do this is we really should establish a positive direction.
well, if we're going sideways, we should go to the right.
The right, okay. All right, so what's the formula for position? Which one should I, now Ibrahim gave us the cosine ones, but there's a sine version as well. I could just as easily have done x is equal to a sine omega t, v equals negative, sorry, that's not right, equals a sine or a omega cosine omega t, and acceleration is equal to negative a omega squared sine omega t. So we have two sets that we could use. Which one makes more sense in this case?
I want to say sine, but I could be totally wrong. Because is sine the one that starts in the middle?
Yes.
If we're starting at equilibrium, that should be the middle point,
Yes.
and we stretch it out all the way to A as an extreme. So yeah, I think it would make sense to start at the middle and go for this one.
The trouble is, when I go from the equilibrium to that outer position right there, I physically pull it out and then I let go.
Okay. Oh, so
So
we're starting at the point
We're starting, yeah, so at time is equal to 0, I was picturing it, or at the extreme, as opposed to we tuned in at that moment when it happens to be passing that equilibrium.
So we should do cosine.
Cosine. Yeah. If you're starting at an extreme, I recommend cosine. If you are indeed starting in the middle, which does happen, if I've got a spring here that's just sitting there and a mass comes along and smacks into it, that's starting at the middle. But if I pull the spring out or push the spring in and then let go, we're starting at an extreme. All right, and not only starting at an extreme, we're starting at a positive extreme. So my amplitude will be positive, or the coefficient will be positive. What is A
Amplitude.
in this case specifically?
5 meters.
Times the cosine of, well, we already figured that out, 0.9036 radians per second times time. At what time, plural, at what times is the speed at a maximum? Oh, what the heck, let's just go ahead and write out the other two equations. V equals
-5. Also 5.
No, I'm good with the negative. Put that part down, negative.
Can you repeat the question?
No, it wasn't a unit issue. What's the formula for velocity?
Negative amplitude, omega sine.
Yeah, you forgot the omega. So it's 5 meters times 0.9036 radians per second.
Oh,
4.6 of the 4.6. Eight.
4.518.
5.8. Units?
Meters per second.
Sine 0.9036 radians per second this time. And acceleration. I've got the negative and the cosine. 0.9036 radians per second this time. If someone could tell me what that amplitude is.
.082 meters per second squared.
Now, did you think meters per second squared because it's acceleration, or meters per second squared because you did meters per second times radians per second?
No, I thought it because of those acceleration.
Okay.
Oh, it's meters per second squared.
Yeah, I mean, you said it right.
Okay.
That, but remember, this is A times omega. And so that was meters times radians per second, which is meter per second. This is that times omega, so meters per second times a radian per second. And the radians just go away because we feel like it. All right, so, well, let me ask you a slightly different question than what I did before we did those equations. What is the maximum speed?
Would you just take the velocity answer and square it?
Or it's just be the amplitude, right?
Yeah, it would just be the amplitude. You're going way more complicated than you need to. So the answer is,
Negative.
4.51 meters per second.
all right, what's the maximum acceleration, magnitude?
4.082 meters per second squared.
All right. You don't have to reinvent the wheel if you've already done that far. All right, so at what times is the speed at a maximum? And as with a lot of these problems, there's more than one way to get there.
Could you make a graph?
Good. All right, so you picturing it on a calculator, type it in, make graph of, or whatever you do in yours, whatever you kids do today.
No, I don't want to do a graph because I don't like graphs unless I have Desmos.
let's see, we don't need, well, we know that by heart, so. So if we did a graph, it's a sine curve, it's negative sine curve, so that's basically what your velocity time graph looks like.
So its peaks, it's 4.518.
Okay, so this is 4.518, and that's negative 4.518.
Would it happen when it's just in the middle of the distance between where it started and the equilibrium, like right in the middle?
No, if I'm reading your mind correctly, you're on the right track. You picked the wrong 2 points.
The extreme, this where we pull it from the like entire end of the stream or spring.
Yeah, so from this extreme to that extreme, it's
Like
the middle
the
of
very-
that.
But did you say it was an ideal spring?
Yes,
So how does it doesn't have an end if it can't interfere with itself?
right, but as you compress it, the force is in that direction.
Okay.
And then it'll be pushed that way, and then it'll be in that direction,
So it's,
So it's like halfway through
which is otherwise known as,
the equilibrium.
yes, that's where the maximum speed is. It's getting faster and faster and faster until it gets to this point, and then it starts slowing down. And then it stops, turns around, comes back. All right, so at what times does it pass through equilibrium?
Well,
that diagonal between the two maximums, the maximum, like that line going up from, yeah,
no, it'd just be at the peaks.
Yeah, it would be at the peaks for maximum speed.
Yeah. Do we know the whole distance of the spring?
It's more than
More than
5 meters.
Okay.
That's all we know.
Well, I was gonna do like if it was like 10 or something, you could just divide that by 2 and then see how long it would take 4.519 meters to get there.
The trouble with that is that's not a constant speed. All right, there's the simple way and there's the harder way of doing it. Let's do it the harder way first. Unless, Joey, you were doing some hand gestures. Did you? Okay. That strangely had a look of fear in it. You shook your head. All right, so here's the harder way. I know that it's gonna happen. I want to figure out when the velocity is 0. Sorry, I want to figure out when the velocity is negative 4.518 and positive 4.518. So I said negative 4.518 sine of 0.9036 t equal to negative 4.518.
and you said it equal to it because,
Well, this is my formula for velocity, and I'm trying to figure out when I'm at my maximum.
got it, okay.
So my maximum velocity, or my maximum speed is 4.518. My velocity will be either positive or negative. So therefore, the sine of 0.9036 t is equal to 1, as we divide both sides by this. And that happens when 0.9036 t is equal to pi over 2. Oh, wait, sorry. Oh, negatives cancel out, pi over 2.
How'd you get there?
If you do, sorry, let me put in the intermediate step. I'm solving for t, so I have to get rid of all the excess junk. So I first have to get rid of the sine, and I do that with an arc sine. So 0.9036 t is equal to the arc sine of 1.
And that I'm assuming is
Pi over 2.
Okay.
If your calculator is in degrees, it will give you 90 degrees. But recognize that this is in radians per second. So 1.5 something. So that out in a moment. And then solving for t, get rid of that last little bit. T equals pi over 2 divided by 0.9036. And that equals what?
1.733.
1.7383 units.
Seconds.
Yep. All right. So that's where the velocity is negative 4.518. That's the time when it's passing through equilibrium going to the left. Now, to solve it for when it's going that speed to the right, when the velocity is positive 4.518, which means that's a negative 1, that's a negative 1, and this becomes 3 pi over 2, or your calculator might do negative pi over 2. I think it probably does.
Why does it change from pi over 2 to 3 pi over 2?
Because when the velocity is positive 4.518, that's when the sign is equal to negative 1.
Mm-hmm.
And the arc sine of negative 1 is 3 pi over 2.
Okay.
If you think of unit circle,
So it's
down there.
Okay. So it's just because you did arc sine of 1, which does equal 3 pi over 2.
Arc sine of 1 is pi over 2. Arc sine of negative 1 is 3 pi over 2.
Okay.
So,
And so now,
did you want the negative answer, or did you want with the 3 pi over
with a 3 pi over 2.
Got it. 5.2151.
5.21
Seconds.
5.21 seconds.
second, okay.
Or it was 5.2151.
All right, that's the hard way.
And so we found those two, one being when it's at its maximum, the one being when it's at its minimum.
When the velocity is at its most positive and when the velocity is at its most negative. Well, be careful about the language there because it's at maximum speed in both cases. Anybody realize the easier way of doing it? It's a chance to stand up and go, can't believe the rest of you missed this.
Do you have to find the first time to find the second time? Or can you do it without doing any of this?
You can do it without doing either of those. When you do a sine or cosine curve, what do you know about those intervals?
They should all be the same.
Yes. That is the period, which we know is 6.9541.
So you just divide it by 4.
Divided by 4, you get this one. Multiply that times 3, you get this one. Does that work? However, there does seem to be an issue here. In the fact that our period over there is not matching what we have. Oh, wait, no. Never mind. I take that back.
Yeah. We could never do anything wrong.
That's right.
Gosh darn it.
Doesn't work. Just wait for all those Nobel Prizes to come in based upon student experiments. So, if you just break this up, think about the period as being the full time. It takes a quarter of the time to get to here, another quarter of the time, another quarter of the time, another quarter of the time. At what times is the acceleration at its maximum amplitude? Or at its maximum value? What is the magnitude of acceleration at a maximum? There we go. You're also seeing samplings of why sometimes the wording in my questions is just awkward.
That's not the right graph. Would
Want
it
me to do a
be?
cosine curve up there for you?
No,
Conceptually, where is the acceleration going to be at its extremes?
like as you let it go,
Okay, that's one spot.
then at the, like when it comes back, or when it turns back around.
Okay.
Yeah.
So when the spring is most stretched or most compressed, that's when the spring exerts the most force. All right, so at what times is the acceleration going to be at its extremes?
So you said when it's most stretched,
Or most compressed?
Would it? I don't know if zero would work.
Yeah, zero, that's one time, 0 seconds.
Then however long it takes for it to get all the way across.
And how long would that be?
The period, for half the period.
Yes, half the period. So I can take my period over there and divide it by 2. 3.4775. So 0 seconds.
Would
And-
it? Sorry.
And the last time,
The period.
within the first period, pardon?
The period.
Yeah. So 6.9541 seconds. I could easily have made a mental error here, so when you go back over your notes, just correct it, or somebody just shout out what the right answer is.
you can do so.
No, you got it right.
Okay.
So
Okay.
This time.
So we found, so we're able to find angular frequency, normal frequency, period, displacement, velocity, acceleration, time when it's at its maximum, time when it's at its minimum, or time when speed's at its maximum, or velocity's at its maximum.
Well, speed's at a minimum when acceleration's at a maximum, and acceleration's at a minimum when speed's at its maximum.